me. When it's cold outside, I've got the month of May.
Okay, on to chapter 7, and 7.1 is solving linear systems by graphing. So the first thing we better figure out is what exactly is a linear system. So up till now you've solved lots of equations. So for example, if I had 3x plus 2 equals 11, what I'd be asking is which number fits in here where the x is to make this true, to make the left hand equal to 11. And you could do a couple things, subtract 2 from both sides, divide 3. Anyway, you'd figure out that the right answer is 3, right? Because if you put 3 in there, 3 times 3 is 9 plus 2 is 11. That's what you've done so far. Now what you're going to do is you're going to have a system. And what a system is, I'll give you an example down here, it's when you have more than one equation. So for example, here you have a system of equations. You have 2x plus y equals 2 and x minus y equals 7. Now, if you compare those to this, which we solved up here, what's different about them? Well, one thing that's different is there's 2 equations here, there's only 1 equation there. And the other very important difference is up here there's only 1 letter, x. Down here there's 2 letters, x, y. And this is always the way it's going to be. If you have 2 unknowns, an x and a y, you need to have at least 2 equations to solve it. If you had 3 unknowns, x and y and z, you'd need to have 3 equations to solve it. But for this year we'll always have 2 equations. And it turns out there's 3 ways. Okay, so first of all, what we're trying to do is we're trying to find a number that fits in this x and also this x. And then a different number, or it could be the same, but probably not, a different number that fits into this y and the same number here in this y to make the top equation true and the bottom equation true. Like, it wouldn't be enough. You could look at this top equation and say, hey, if I made x 1 and y 0, it works. 2 times 1 is 2, plus 0 is 2. It works. But does that work down here? 1 take away 0 equals 7? No, it doesn't work. So those are not the answers. It has to work in both of these 2 equations. Alright, that's what this chapter is all about, is solving systems of equations. This is a system because there's more than one equation. Turns out there's 3 ways to solve systems of equations, and the first way we're going to deal with today is by graphing. Okay, so let's go down. I'm going to skip all this for now. I'm going to come back to it. So if we're solving this system of equations right here, 2x plus y equals 2 and x minus y equals 7. I'll say it again. We need a number that goes into both those x's and a number that goes into both those y's so that the top equation is true and the bottom equation is true. And the way we're going to solve this is by graphing. Let's start by graphing the top one here. Now, there's 2 ways to graph this. One way you could do this is you could easily switch this into slope-intercept form. And the way you could do that is you could just move this 2x to the other side, and you'd end up with y equals, when you move 2x to the other side, it becomes negative 2x, and you still have a plus 2 over here. Okay, and now if that's in slope-intercept form, you have a slope of negative 2 and a y-intercept of 2. So y-intercept of 2, there you go, and a slope of negative 2, but let's think of it as negative 2 over 1. That means rise negative 2, or go down 2, and then over 1. And we could do that a couple times. Down 2 over 1, down 2 over 1, and if you give me a second here, I'll draw a line through there. Now, remember, this line here, I want you to remember the important relation between this equation, 2x plus y equals 2, and this line. Basically, this line here, this black line, is made up of an infinite number of points, right? Point, 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 goes on forever up here. Point, 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 goes down forever there. Every single one of these points can be identified as an ordered pair. So, for example, this point right here, this is the point 2, negative 2. This point here is 3, negative 4. This point here is 0, 2. And it turns out that every single one of these points will work when you plug it into this first equation right here. So let's try it. If I put this point here, 0, 2 in there, I get 2 times 0 is 0 plus 2 equals 2. That's true. If I put the next one in there, I go 2 times 2 is 4 plus negative 2 is 2. That's true. If I put this one here, 2 times 3 is 6 plus negative 4 is 2. That works. Every single point in here works. Okay? But that doesn't necessarily mean that it works on this point, this line here. So now we better graph that line. So how are we going to graph this line? Well, again, you could do switching it into slope-intercept. But remember, the other way you can always graph these if you want. I'll do this one the other way. You could do the x and y and find the x-intercept and y-intercept by putting a 0 here and a 0 there. Right? If I'm looking for the y-intercept, I put 0 into the x, so I put 0 here, and I'm left with negative something equals 7. Well, it must be negative 7 to get positive 7. This has to be negative 7. Okay, if I am looking for the x-intercept, I put y into the 0. So I just get x equals 7. There you go. There's your intercept right there. X equals 7. So we can graph these 2 points. 0, negative 7 is down here, and 7, 0 is out here. And now I'm going to draw a line through those points, and I'll make it red. Okay, there we go. So this red line is also made up of an infinite number of points, goes through all sorts of points here, and every one of those points will work in the second equation. Let me erase this. Okay, so every single one of the points on this line will work here. So for example, this point is 7, 0. Yes, 7 take away 0 is 7. This point is 6, negative 1. 6 take away negative 1 is 7. Good. This point down here is negative 2, negative 9. Negative 2 take away negative 9 is 7. They all work. So this highlighted equation, all the points on the black line satisfy that equation. This red line, all the points on that line satisfy the second equation. Where's the point or points that satisfy both of these equations here? Yes, you guessed it. The point that satisfies both of them are where they cross each other. This is the point right here that satisfies both of them. So your question becomes, what's that point? What's the point where they cross each other? That point is 3, negative 4. And this is our solution. The solution to this problem is 3, negative 4. Now, maybe you don't believe me. You're like, well, I'm not sure if that's really actually true. Let's try it out. Let's make sure it is actually that answer. If I put 3 here and negative 4 here, what do I get? Well, 2 times 3 is 6, and then plus negative 4 is 2. It works. If I put 3 here and negative 4 here, I get 3 take away negative 4. That equals 7. It works. This is absolutely the point that works. This is solving by graphing. So let's go through the steps. Lots of writing for you here. The first step is you're going to graph both equations on the same grid, right? We put both of them on the same grid. You got to do this very accurately. Second, make sure you use a ruler when you do this. Don't do this by hand. It will not work. Second step, see where the graphs intersect. If they intersect, they might not, and we'll talk about that in a second. The ordered pair or pairs where they intersect is the solution to the system. So this is where they intersected, so that was the solution right there. Step 3, you can check your solution if you want. You don't have to, but it's a safe thing to do. You can check your solution by substituting the ordered pair back into both equations. It must work in both of them. If it only worked in the top equation, but it didn't work in the bottom one, that's not good enough. It has to work in both of them. Okay, let's do another one, and then I'll start talking about the 3 possibilities. So these ones you definitely want to do slope-intercept form because they're both already in slope-intercept form. So the first one has a y-intercept of 5 and has a slope of negative 2, which is the same as negative 2 over 1. That means down 2 over 1, down 2 over 1, down 2 over 1, and I'll draw a blue line through that. Okay, there you go. There's your line. And remember, all the points on that line satisfy this first equation. Now we're going to graph the second equation, and I'll do this one in red. So we have a slope of 1, right? In front of the x, there's a 1, and we have a y-intercept of negative 4. So I go to negative 4, and I put a dot, and then slope of 1, which is the same as 1 over 1. So I go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, and I will draw a red line through there. Okay, there's the red line, and all the points on that line satisfy this equation here. So where's the point that satisfies both of those equations? It has to be the point that they cross. It's this point right there. So what is that point right there? That point is 3, negative 1. My answer is 3, comma, negative 1. That's 3, not negative 3. 3, negative 1. So let's highlight that so we can see it well, and let's check it. Let's make sure that is the actual answer. So let me get rid of all this. I'm using highlighter way too much today. If I put 3 into the x and negative 1 into the y. Okay, negative 2 times 3 is negative 6. Plus 5 is negative 1, and that's exactly what it's supposed to equal. That works. If I put 3 into the x and negative 1 into the y. 3 take away 4 is negative 1. That works too. This is definitely the right answer right there. Okay? All right, so there's three possibilities. The first possibility is that, if I can find it here, there's only one solution, and that's what we're getting here. We're getting only one solution. So this will happen when the lines intersect at only one point, of course. They crossed at this one point. They crossed at this one point. The two lines have different slopes. Yeah, different slopes, different slopes. This will always be the case when you have one solution. And what we say is that this is a consistent system with independent equations. Okay, and that'll make a little more sense once we show you the other possibilities. But before I show you the other possibilities, can you think of what the other possibilities are? When you have two lines, because that's all we're talking about this year, we're talking about linear systems, so it's only lines. What I'm interested in is how many ways can they cross each other? So we've shown they can cross in one way. How many other ways can they cross? Think about that for a moment before we move on to this. All right, I think it'd be great if you kept thinking about that, but chances are you didn't. All right, if we're going to graph this first equation here. Now, you could graph it like this, using my intercepts, but you'll find a problem there. If I put 0 in here, then 10 times what equals 30? 3. That's good. If I put 0 in here, then 4 times what equals 30? Well, it's not a perfect whole number. It becomes 7.5. But it still works. You can still do that. So what the heck, let's go for it. 0, 3 is here, and 7.5, that's a 5, not a 3, 7.50 is right there. Now you want to do this as accurately as possible, because remember, our answer is where the two lines are going to cross each other. So I'll draw a purple line through there. Okay, there we go. This is the line. Every point on that line satisfies this equation. Whoa, hard to see. Okay, let's do another one. Let's do this one here. If you did this one with this x and y-intercept method, you do end up with a problem. Because if you put 0 into x, what do you have to multiply 5 by to get 35? 7. Okay, that's fine. 0, 7, no problem. But then if you put 0 into here, so that's 5 times 0, 0, 2 times what equals 35? 17.5. Well, 17.5 is way off my grid. You can't graph it. It's not going to work. We need a different method. So, or we can get a bigger graph. But I'd like to use this graph since it's already here. So what's the other way we can graph? We can switch this into slope-intercept. So we want to get the y by itself. So let's start by moving the 2x to the other side. It becomes negative 2x. And we still have plus 35. Then what we need to do is we need to get rid of this 5. Since it's 5 times y, we'll divide by 5, and we'll divide everything on this side by 5 too. These two are going to cancel. So what we're left with is y equals negative 2 over 5x plus 7. That gives us a y-intercept of 7. Yes, we already had put that there. And our slope is negative 2 over 5. That means rise negative 2, or down 2, and run 5. 1, 2, 3, 4, 5. Rise negative 2, down 2, and run 5. 1, 2, 3, 4, 5. And I will draw a line through there, a red line. Okay, all the points on that line satisfy this equation. Now, what do you notice about these two lines? They are parallel. We get a solution whenever the two lines cross each other. When are these two lines going to cross each other? Never. They are never going to meet each other because they are parallel lines. What does this mean? This means there is no solution. There is no x and no y that you could put into these two spots, x here, y here, that would solve both of these equations. Here's something else. What's the, let's just quickly, because I don't want to take too much time with this, let's quickly switch this top equation into slope-intercept form as well. So we'll leave the 10y here, we'll move the 4x over, you get negative 4x plus 30, and then we'll divide everything by 10, by 10, by 10, this cancels. You get y equals negative 4 over 10, which is the same as negative 2 over 5x plus 3. What's the slope of this equation here? Negative 2 over 5. What's the slope of this one down here? Negative 2 over 5. They have the same slope. That shouldn't be surprising. We know parallel lines always have the same slope. What's the y-intercept here? 3. What's the y-intercept here? 7. 3 and 7. So they're parallel lines, they have the same slope, but they go through the y-intercept at different places. These will always have no solutions. This is the second possibility. So, no solution. This is when the lines are parallel. They never intersect. The two lines have the same slope, but they have different y-intercepts. And what we call this is an inconsistent system. Inconsistent because we get no solutions from it. This is a consistent system because we get a solution from it. and they're independent equations. That gives you a hint perhaps for what the third possibility is. Have you figured out the third possibility? Here it comes. You can bet I gave one of each possibility. So let's solve these ones. Let's do both of these by switch them to slope-intercept form. So we're going to get this y by itself, but I also want this y to be positive. So let's move the negative 6y to the right-hand side. So we have 10x. I'm going to move this negative 12 to the left, so that gives plus 12. And as I said, the negative 6y comes to the right, so that gives you 6y. Now I need to get the y by itself, so I divide by 6, divide by 6, and divide by 6. What's that leave us with? Well, these are gone, so I get y equals 10 over 6 is the same as 5 over 3x, and 12 over 6 is plus 2. So let's graph that first of all. Y-intercept's 2, and the slope's 5 over 3. Rise 5, run 3. 1, 2, 3. And I can't go any more that way. You could also go down negative 5, like go down 5. 1, 2, 3, 4, 5. And to the left 3. 1, 2, 3. Why does that work? Because that's a negative move and a negative move. And two negative moves make a positive move, just like this slope here is positive. Okay, let's draw the line. I'll make it blue. Okay, great. Now let's deal with this second one here. I want to get the y by itself. Oh, easy. All I have to do is divide everything by 21, by 21, by 21. So this cancels out. I'm left with y equals, let's do the x first, 35 over 21. I can divide them both by 7. So that gives me 5 on the top, 3 on the bottom, x, and 42 divided by 21 is 2. So I get 5/3 x plus 2. Let's graph that. That's a y-intercept of 2. Oh, same y-intercept. And it has a slope of 5 over 3. Up 5, 1, 2, 3, 4, 5, over 3, 1, 2, 3. What? It's exactly the same line. If I was to draw that line, it would fall exactly on top of here. Don't believe me? I mean, you have to believe me. If I was to draw the line, it would be right on exactly the same thing. What does this mean? We said you get a solution wherever the two lines cross each other. How many places do these two lines cross each other? Infinite number of places. There are an infinite number of solutions. Now, when I say there's an infinite number of solutions, does that mean that everything is a solution? No, it doesn't. It doesn't mean this point's a solution. It doesn't mean this point's a solution. This point's not. Every point on this line is a solution. So pick any point on that line. I don't know. Let's pick this point right here. This one. What point is this? This point is negative 3, negative 3. It should work. If I put negative 3 here and negative 3 here, it should work. 10 times negative 3 is negative 30. And take away, 6 times negative 3 is negative 18. That means plus, negative 30 plus 18 is negative 12. It works. If I put negative 3 here and negative 3 here, 21 times negative 3 is negative 63 equals 42 plus 35 times negative 3 is negative 105. And if you do 42 plus negative 105, you'll get negative 63. It works as well. Every single point on this line, every single one of them will work. There's an infinite number of solutions. This is the third case. So the third case is infinite solutions. This is when the lines lie on top of each other. In other words, it's the same line. The two lines have the same slope and the same y-intercept, obviously, because it's the same line. And this is called a consistent system again, because there are, again, some answers. But they're dependent equations. Independent means separate from one another, right? So that's why this one's independent equations, because they're different lines. This is the same line, so it's called dependent equations. So a little bit of vocabulary for you to learn there. So that's it. That's how you find solutions to linear systems of equations by graphing. Now, I'll leave you with a question here. What are 3 disadvantages to solving by graphing? This isn't my opinion, but in my opinion there's 3 disadvantages. One is it takes too long, right? Switching these things to slope-intercept form and then graphing it, getting your ruler, drawing them, finding all that kind of stuff takes time. And in my opinion, it takes too long. The second reason I don't like it too much is, what if the answer does not fall within the region of the graph? Like, I made sure that all of these solutions we found are all in this graph. But what if it wasn't? What if my solution was at negative 62, 54? It's possible that your x value is negative 62 and your y value is 54 and it works. But man, you'd have to have such a big graph. And how would you know that it had to be that big? It would take you forever to figure that out. So this is one time it just is not a good thing. A third reason I don't like it very much is, what if the answer is not a pretty point? right? Again, I made sure that all my answers were pretty point. But what if the solution was not a pretty point? What if the solution was at something like 3.6 and 1.4? Right? That's very valid, could be a very valid answer, but it's going to be next to impossible for you to figure that out. If you had your two lines crossing and they crossed right there, and you said, okay, there's my solution is right where they cross, right there. Well, I don't know exactly what that point is. Is the x value of that 4.3, 4.4, 4.5? Is the y value negative 6.2, 6.3, 6. It's too hard. So for all these reasons, I think that it's not very accurate to use graphing, and that's why we have two other methods which are much more preferable. Yes, you do need to know the graphing method, but once you learn the next two methods, you're going to realize that this is not the greatest method to use. When you're doing your work, I promise you that all your answers are going to have whole numbers, pretty points, or if they're not, they're going to be like half. They might be like 2.5, but you'll never have an answer like 2.1 or 2.2 because you'll just would not be able to figure out what the answer is.
I guess you said what can make me feel this way, Maggie, talking about